Hello everyone, my name is Henry, I'm from Central. I'm happy to contribute to this year's edition of the conference. This talk is about Google Santa, a binary authorization system on macOS. I hope to share some ideas that may help in planning a Santa deployment. We take a quick look at Google Santa and what is required to run it. Then we look into collect information about the executables that we want to control. Once we collected and compiled our data, we see an example on how you can manage rules and policies across the fleet. Ahead of running a binary authorization system, you best clarify a few questions. Who is the type of user that will work on the system controlled this way? What level of binary control is targeted? Do you simply want to block the one known disruptive app or vendor? Or is it about creating a governance framework that can be customized over time and works across all corporate Macs? When do you need to update your rules and policies? Which interval is sufficient? Can users request exceptions? And so on. Also, where do you operate the sync server? And finally, why do you care? Is it a topic you can safely ignore in your org? Maybe. The details how Santa works have been covered in previous presentations. Here's just a brief outline. Santa runs a daemon that makes execution decisions. The decisions are based on a fingerprint of an executable program part and are derived from the code signing certificate or the hash of the binary file. A GUI agent can notify the user in the event of a blocking decision. For admins, a command line utility helps to get the file information and also check the status with the sync server. Santa is already a modern endpoint security extension that Apple has introduced in macOS 10.15 to replace kernel extensions. And as mentioned, you can set up a sync server where the rules and policies are going to be provided centrally. Santa rules consist of one target type, that is either certificate, binary, or bundle. For the defined target, you must specify the associated SHA-256 fingerprint. And for each rule, you need to set a policy. There's a allow list or block list. Santa uses a local database to store the rules and policies and event-related data. In standalone mode, the rules need to be set with the santactl command line tool, but the best way to use Santa is to have a sync server. Okay, what is needed to deploy Santa fleet-wide? You must work with an MDM to install some payloads. The main configuration is a custom mobile config where the most settings are static key values. Only a few parameters can be updated dynamically by a sync server. Of course, you need to deploy the Santa package, but before that, you want to install additional payloads via MDM, so Santa will work smoothly. A system extension policy control payload. This allows the system extension to be activated enabled. A PPPC payload to give Santa full disk access, and a notification payload. In terminal, you can check all is in place as shown in the screenshot. The sync server config is well documented. Client mode works dynamically, so with the initial config deployed, you can later switch from monitoring to lockdown when using a sync server. Santa can also use a regex to allow or block by path. This is useful for a developer workstation. In a mutual TLS setup, Santa will look up the desired device certificate from the system keychain. And it's also nice to specify an info URL that the end user can visit on blocked executions. The most interesting question is to whether run Santa in lockdown or monitoring mode. In lockdown, only the approved vendors and binaries can run. All other binaries are not allowed to execute. This is the default deny mode. So in the end, it's worthwhile to put lockdown mode into operation, at least in parts of your fleet. You want to gather the data about the apps and executables from the typical vendors and applications that are used in your fleet. With that information collected, you can prepare the rules to allow them to work even in a lockdown mode setting. The best way to gather the data is to use the santactl command line tool. It quickly and recursively can scan the applications and binaries on a sample system. Other good sources are to examine the binary execution events written to a data store. This can be the local Santa log, or it can be a data store like Splunk in other setups. Once you have collected the data, you can refine all info and compile it more accurately, and build a clean set of rules on this basis. If you examine metrics about the executions from either the local Santa log or in a data store, you may find that allow unknowns are reported in large quantities. This could be the GEMF binary or similar management agent. Congratulations, you have discovered the good candidate to be included into an allow list. Here we see the allow unknowns are frequent events happening many times per minute. But once a rule is set for this executable, we see that the events are no longer returned to the sync server. It's worth to mention here that all binary execution events, including the known ones, are still written to the local Santa log, so this can be examined for audit purposes if needed. Odd things can happen anytime. For example, Apple recently released a new Leaf certificate for Launch D and many other macOS binaries, while other macOS binaries in the same OS release have been still signed with a previous certificate. Therefore, it's recommended to add an allow list policy for the known Apple certificates to avoid issues. Santa allows you to fill in data about a block decision so the user can send this to a predefined URL. This allows you to create an exception portal in a web form. Users can post a request to unlock, and you can review the data and even run automated processes behind the scenes. And you can even limit a rule to certain criteria, like the principal user. With the fingerprint information collected, you can begin to process this into organized rules with a clear allow list policy set. Again, this is useful when you switch to lockdown mode in the future. And it may be worth looking how to group the rules by determined levels or criteria. Start with the must-have rules. These are the management agent tools and other mandatory apps. For the next layer, pick the mandatory apps that should run in default. Also, when you switch to a containment scenario, these could be the communication tools like Slack. The next layer could be a large amount of apps for the normal operations. And of course, you should define in advance the known bad vendors and apps that you want to block in general. Okay, plan of actions. Let's run a short demo on it. We collect raw information with SantaCTL. We process the JSON results and convert them into a raw set of rules. For this, we use the JQ and YQ tools in our demo. In our script, we use the SantaCTL file info to gather information on the code signing. We use the cert index and gather also some metadata. We process the results of the SHA-256 to get the certificate information and attach a rule type. We run the same process with SantaCTL file info for the executables. Again, we collect all the SHA-256, we process them, and we set a rule type for binary. And you will see that we get a result of JSON and YAML files all the way down. If we inspect the JSON file, we can see a nice deduplicated list of all the code signing information, a rule type set to certificate, and a policy allow list already compiled in one file. And the same processing has been done on the binary side. Here we have some more metadata and it's much more granular information. But again, we have created a rule type on binary and a policy to allow list. The ultimate question might be, what balance can you achieve in lockdown versus monitoring? Every organization is different, therefore there's no general rule. But make it a creative process or exercise to work on a strong result here. The goal is to achieve a maximum percentage that you can run in lockdown mode. But who says there can be only one silver bullet? Why limit yourself to one configuration? You can organize 2 or even more Santa-based configurations. Use the common rules across the configs and set the specific rules and policies on another config or use criteria like the principal user. Also for developer user profiles, Santa has unique features like regex and transitive rules that might work better than you assume. This is an example sketch of layers with different rule sets and Santa configurations in place. You can stagger the rules per configuration. The rule set A here is attached to 2 Santa configs, so these rules run on all endpoints. The next layer is the rule set B. This is also set to both Santa configs. And then we have the rule set C, which is only attached to one of the configs. Of course, you should track the changes of your rule sets via Git and ideally have a GitOps workflow in mind. And you want to be able to pull the rules back to the bare essentials, like switching into a containment mode. This may allow only the management tools and a few vendors to be allowed to execute. This could work like a panic switch. As long as it's active, only the minimum required apps and management tools are allowed. You apply the defaults deny to all targeted endpoints by running in lockdown mode. In case of emergency, you can control the events almost in real time in a data store, and you always know the rule sets of what should be allowed as a minimum. And you can take advantage of the ability to quickly bring back apps on a granular basis. The plan of action now with a second demo. Here we use GitHub Actions. We use the Central HTTP API, and we use Central as our Santa sync server of choice. Here we start with the Santa configuration and 0 rules attached. And on the GitHub side, we have rule sets that we prepared, and we run a GitHub action to apply the rule sets via the HTTP API into Central and apply this for the existing Santa configuration. The GitHub action is triggered, and we can inspect the details shortly. And we will see now it's finished. And from the 3 files that we had in our source here, we see that the first file created 11 rules, the second file created 17 rules, and the third file created 2 rules. Now, if we refresh on the Central side, we see there's a total of 30 rules, and we can look into them and we can filter them. Here's the 2 blocking rules. Then there's the core essentials of the services. And then there's the third rule set, which is the main software rule set. And it's interesting to see here that there's a primary user set for that policy, or set for that rule. And what if another user wants to have this rule attached as well? Well, in a reviewed process demoed here, we see there's a new user attached to that specific file. This looks okay for the reviewer. Now the pull request is merged. And again, a GitHub action will be triggered in the background that reaches out to the Central HTTP API to update the existing rule. And this happens in an idempotent fashion. What you have in Git is represented on the Central side as well. Now the merge job has been done. And we can see, if we scroll down to the specific rule set, that 1 rule has been updated. We double check this on the Central side, and now we see 2 primary users are attached to that specific rule. Voila! Recently, we have completely redesigned our Santa module in Central. It's more easily to organize the rule sets across multiple Santa configurations. We support Santa advanced features including mutual TLS. The HTTP API for rule set management runs in a full idempotent operation. We also have an HTTP endpoint for ingesting SantaCTL file info, which brings the metadata into the web GUI. And last but not least, we offer the GUI operation for rule management as well. Next to our Santa module, we also have overhauled OSQuery in the same way. The idea is to work with the declarative management and configuration in code as much as possible in Central. Along Santa and OSQuery, we support many extra inventory sources. You can fully manage Monkey from Central and see all the events from Monkey as well. All of this can be deployed in a scalable way based on cloud-native services. Role-based access, service accounts, single sign-on, and realms is available to meet the needs of larger organizations. And we provide flexible support for the multiple primary event data stores like Splunk, Elastic, Datadog, Azure Log Analytics, and others. All this and more is available as full open source, and on top, we provide professional services in a custom engineering. To learn more about Central, we also have held a workshop 2 days ago. The full video should be available soon. Now, a quick summary to wrap up because we're running out of time. The essence is that you need to know what to authorize for whom in order to make binary authorization effective and reduce the friction for the end user. Once you formalize the required tasks and processes, you effectively raise the bar for security in your fleet. And of course, lockdown mode is the goal here. Consider lockdown for a certain percentage of your fleet. Be prepared to update rules and policies in a fast time frame. And do not limit yourself on the sync server side. Having multiple configs is manageable. Besides Central, another option would be to run 2 instances of Moros, which is another great open source sync server project. Build up an in-house library of rules and metadata on the executables and start keeping control with Git-based workflows. Even collect the data of embedded binary in the main software rollout. Then you'll know exactly what to block and what to allow in doubt. SantaCTL is the best tool to determine this info. Here are valuable links I will share, also a GitHub repo with the slides and some references back in the Discord channel. And with this, we're almost out of time. Thank you for listening. Here's my contact information and I'm available for the Q&A on Discord right now.